So the basic concept of the radians and its applications to the add math will be covered in this fragment. So whenever you're talking about the radians, now first thing that comes is that what is radians? Now, logically speaking, now when you say uh, there are two units in including DP and any other courses, so that is we refer as degrees. So one is degree, another is radians. Now, when you talk about the radians, now let's say you're sitting around um, the center of a circle of a unit radius, and if you rotate, let's say from here, you rotate 360 degree, or you keep a protractor here and measure the total angle. Angle is going to be 360. But what happens is that if I talk about, let's say, equivalent length, let's say the person is covering along the circumference here. Uh, if you talk about the circumference, this part is actually nothing but 2 pi times radius. So 2 pi and radius is 1. So you get 2 pi. This value is actually when you say I can set up an equivalence. Okay, if I rotate 360 degree at the center, I'm actually tracing 2 pi length on the unit circle. I mean this along the circumference. So actually now when you talk about the radians, the 2 pi length that you got here is actually equivalent to 360 degrees. It's not equal because these two are different things, but their significance is the same. So when you talk about the now here, it's pi is equivalent to 180 degrees. So sometimes you see a cap C that is indicator of a radian. So pi radian is actually 180 degrees. Now this gives us a way to convert the measurements from degrees to radians. Now, if you wish to convert an angle from degrees to radian, you multiply by pi by 180. And if you want to convert from radian to degrees, you multiply by 180 by pi. So the first thing is that what you got to understand is that how do you convert the measurements from degrees to radians and radians to degree? So you have got a shortcut here. Multiply by pi by 180 to get into radians, multiply by 180 by pi to get into degrees. Here, let's take an example. So let's say if you wanted to convert, let's say 30 degrees into radians. So let's say I want to convert into radians. So 30 degrees, I have the multiplier as pi by 180. So pi by 180 is a multiplier, and here we get is pi by 6 radians, if you simplify this. So 30 degrees actually equivalent to pi by 6 radians. Also, if I look at, let's say 90 degrees. Now 90 degrees, I can say is 90 times pi by 180. So that is going to be pi by 2 radians. Now, if you wish to convert from radians to degrees, let's say I got 5 pi by 6, and I wanted to convert to the degrees. Now this you got to multiply by a 180 by pi by 180. This is pi by 180 is for degrees to radian. You multiply by 180 by pi. So this gets cancelled. This simplifies, and you get 150 degrees. So 5 pi by 6 is actually 150 degrees. So that's how you make the conversions between degrees to radians. So now what we're going to do is I'm going to quickly take some of the applications, how radians use of unit changes, the geometry application formulas. Now the first thing that comes to your mind is the sector. Now when you look at the sector, so sector is actually when you specify the angle here, so this is theta, and the radius of the circle, and length of the arc is L, and the area of the sector is A, let's say. So the formula is in the degree unit for this is like when you want to cover for the, let's say L, that is the length of the arc, actually it is the theta over 360 fraction times 2 pi r, where this is the length of the arc, because you can see this is total is 2 pi r, and out of theta fraction is allotted to this part, which is L. Now for area of the sector, it is theta over 360 times pi r square. So these two are the formulas that we use for area and the length of the arc of the sector in degree unit. Now what happens is if the unit is, let's say, given in radian already, I have a way to find out, let's say, if this is already in radian. Now, do I always convert back the angle to radians, or can I have these formulas explicitly converted for the radian measurements? So I can just simply put a correlation here. Let's say if I got um, in this part, when you say length of the arc is theta over 360 times 2 pi r. Now this angle is in degree. So this angle is in, let's say, degree measurement here. Now what happened is that if I look at in this part, what I can look at is that if I say that pi radian, we just showed the equivalence that pi radians is 180 degrees. So I can actually say, okay, this is 2 times 180 and this is 360 and 360 get cancelled. So actually we get the length of the arc formula is r theta, where theta is in radians. So when theta is in radian, you can use this formula directly. So theta is in radians here. Similarly, when you talk about the area of the sector is actually theta over 360 times pi r squared. Now, when you say, okay, pi is equivalent to 180 degrees, so this 180, if I cancel this with here, I get actually half r squared theta. So this is the quick math formula for finding the area of the sector when you have been given the measurements in radian for the angle. Now let's just remember this always, that okay, length of the arc is r theta and area is half r squared theta. And if it is in degrees, you already are comfortable with it. So let's take an example of how do we apply this. So first I'm going to take one example in, let's say, degrees. Suppose this is 30 degrees, this is 10 meters radius, and I wanted to find out what's the length of this arc and area of the sector. So now when you do this, the area of the sector is 30 over 360 times pi times 10 square. That's in degrees, and you can find out these values as well. And the length of the arc is 30 over 360 times 2 pi r, which is 10. Now, if you wanted to do in degrees, radians actually here. So 30 degrees, if I want to convert to radians, 30 times pi by 180. So it is pi by 6 radians. So when you have pi by 6 radians, it is, what we can do is we can simply write down the formula for the length of the arc here is going to be pi by 6 times 10. That's your length of the arc is r theta. And the area is half times r square, which is 10 square times theta, which is pi over 6. So you can put these values. And remember here, pi is actually 3.14, like usual value that you take. Once you convert to radians, it is the normal pi value. So don't need to, this pi is not different. Okay, it's the same pi value that you use. So let's take another example. So let's take some more examples on the concepts of the formulas that we used. So what happened is that, let's say, I'll just quickly write in the formulas in radians. Length of the arc is r theta. So the length of the arc, that is r theta, and area is half r squared theta in radians. When the angle is in radians, you could use this formula. So the questions that I'm going to use are A, B, and C here to understand this concept. Now the question here is that they have given us to find out theta in every case. So here the question is, length of the arc is 6 and radius is 8, and you got to find out theta. So if you look at this formulas, I can simply use this one here, which is length of the arc. So 6 equals to, radius has been given to you as r, which is 8 times theta. So theta is actually 6 over 8. So theta is 6 over 8 here, which is 3 over 4. Now, here in case if you look at the next part, the the length of the arc is 8.4. So 8.4 equals to theta times r, so 5 times theta. So you get theta as 8.4 over 5. Now, when you look at the next up here, when you're finding this angle, so first let's calculate this angle. Let's say I have got this angle as x, radians. So I get, okay, 31.7 equals to 8 times x, because my sector that they have given for the length of the arc is 31.7 centimeters. So x is 31.7 or 8, whatever this answer you get. And remember this now to get this theta. So angle around a point now, which is 360 degree, and in radians, angle around a point is 2 pi. So what you're going to do is, after you get this answer x, you're going to do 2 pi minus basically 31.7 or 8. So the whatever the answer you get, subtract from 2 pi. Don't do 360 minus, because now you're dealing in terms of radians. Okay, so now these concepts that I'm going to cover now, they will require some of the skills that is linked with the sine, cosine rules. So more specifically, cosine rules. So cosine rule, and I would say that it might be linked up with the area of triangle formula. So in case if you're not clear with any of these rules, you better just revise them. So what exactly is the cosine rule? I just quickly touch base upon. It's, even though I covered in my previous segment. So just cosine rule is that when you have been given two sides, let's say two sides, let's say here is A, B, and C, and you have been given an included angle, maybe X. So in case if you wish to find the side which is opposite here, you can just apply like a Pythagoras theorem type of concept, like A square plus B square. But there is additional term which is negative 2ab times cos x. This is why it is called cosine rule. So you're going to do, you can remember in this way that if I use c, c is never going to be used. So you do a square plus b square minus 2 times a times b times cos x. So this is the cosine rule. So if I can take an example like, okay, this is 10, this is 20, and this is 40 degrees. And I want to find out what's the measurement of c. So you can say c square is 10 square plus 20 square minus 2 times 10 times 20 times cos of 40. And of course, you got calculator, you can work it out. The next part is the area of triangle. Now, when you have been given two sides, now generally we use the area of triangle as half base into height. Let's say base times height. So let's say this is base and this is height. Now, what if the triangle is non-right angle triangle? So in that case, if you already know two sides and an included angles, the angle must be between the two sides. Like for example, this is 10, this is 20, and this is 40, as I took this example here. It can be written as area is half times 10 times 20 times sine of 40 degrees. So this is a straightforward formula. This is, you can just remember this. It will be half a times b times sine x, where x is the angle between these two sides. So two sides, a and b, included angle x, area of this triangle is given by this formula. And you can use calculator to find out the answers out here. So this is a prerequisite for these concepts. If you don't know these, you might have struggled. That's why I covered this up. So now I'm going to just take questions where you apply these formulas together. So first example that I'm taking is, actually, let's say if you got a circle here, I'm just gonna draw a proper circle. So I'm just selecting a circle, let's say here. And now what has been given to you is that the center of the circle is, let's say, O, and it has been specified as, here it is, let's say this is 40 and 40, let's say meters. This is, let's say 40 meters in the radius. And they have given us that this is the angle that is, let's say, uh, a pi, 2 pi by 3 radians. So now they have given the measurements in radians. So what I'm going to do is I'm going to find out the area of the shaded part, as well as, so the question here is to find out the area of the shaded part, area of shaded part, and the perimeter of shaded part. So how do we do that? So when you're finding out this, now first thing is that if you look at the entire geometry out here, now let's talk about the area first. So if I look at the area of the shaded part, so A shaded is going to be A sector minus A triangle. Now, what is that triangle that is getting formed here? So A and B is a triangle, OAB is a triangle, and area of the sector you already know here, the formula. And the area of triangle also we know. So we got to use these two formulas to get the answer. So area of sector here is half times radius is 40 times 40 square times theta is just 2 pi by 3. That's your area of the sector minus area of the triangle. So area of the triangle is half a times b. So if you see this formula, a and b, these two are the radius here. So a is 40, b is 40 times sine 40, sine 2 pi by 3. So sine 2 pi by 3. Now you got to keep your calculator in radian mode. You can just input this and you'll get the exact answer. That needs to be done very carefully. Now coming back to the perimeter of the sector, I mean perimeter of the shaded part, not the sector here. So perimeter of shaded part actually is this part that I'm shading up in little bold color here. Let's say this part, which is this perimeter of this particular fragment I got to cover up. So how do I do that particular part? Now, first thing that comes to my mind is that here, this part is nothing but the length of the sector, which is r times theta, which is 40 times 2 pi by 3. You got this. So you can just say, okay, this is 80 pi over 3. That's your this answer. And now if you want to find out, let's say, this leg segment here, you can use this formula that is cosine rule. So cosine rule, if I use here, if I take this as, let's say, c square is going to be 40 square plus 40 square minus 2 times 40 times 40 times cos of 2 pi by 3. So if you look at this formula, a square, 40 square, b square, 40 square, 2 times a times b, 2 times 40 times cos x, cos of 2 pi by 3. And this can be calculated using your calculators. You can find out the C value. And of course, you got to root this answer to get the exact C value. And you got to add to this particular length in order to get the perimeter. So this is the objective of this lesson. This is the entire key concept that is covering up the particular properties that is relevant for radians.